Welcome to section 6.2. We want to look first at the intro, and we're going to use the idea of law of sines one more time to just make sure we're set there. And so here's what we're going to do. Let's take a look. We know two angles, 82 degrees and 31 degrees. We also know the other side, which is side A, which is 12. Okay, so let's draw a picture. Let's say here's 82. All right, here's an 82 degree. Here's 31 degrees. So this is angle B. This is angle C. Across from angle C is side C. Across from angle B is side B, which gives us angle A here and 12 for side A. And actually, I'm going to say equals side A. Okay, now let's put in what we know. 82 degrees, 31 degrees, side A is 12. And what condition do we have? I have an angle, an included side, and an angle. So this is angle, side, angle. And that's good for us because we know the side angle condition is the one that causes this problem. So this will most likely be a triangle. So where do I want to start? Angle A, I can do 180 minus 82 minus 31. I end up getting 67 degrees for angle A. Now, as I look at this, angle A is the middle angle, so this should be my middle length of 12, which means side C should be bigger than 12, and side B should be less than 12. And that's kind of the mindset as you go through. If you're getting answers that are different than that, then we probably did something wrong. We want to start by putting the 67 in because we want to use the corresponding side and angle. So here we go, the sine of 67 over 12, and I'm going to go B first. The sine of 31 over B. When you cross multiply, 12 times the sine of 31 equals the sine of 67 times B. And we divide the sine of 67. Therefore, side B is approximately 6.71, which is a good thing because, again, the length should be shorter than side A. If we do the next one, the sine of 67 over 12 equals the sine of C is 82 over C. Then I have C times the sine of 67 equals 12 times the sine of 82. And I divide by the sine of 67. C is approximately then 12.91, which again is good because that length should be bigger than 12 since the angle is bigger than 67. And so this goes back to the law of sines, which tends to be a lot easier than the law of cosines as we go through. And again, because it was an angle side angle condition, we knew that we should get an answer. So that's what we did in 6.1. Now let me show you how the law of cosines came about. And then what we're going to do is actually practice a couple examples. Okay, so we're going to draw a picture first. And I'm going to put this on a coordinate plane. Okay. And I'm going to make angle A at the point 0, 0. And I'm going to put angle, the point B somewhere on the x-axis. And I'm going to put C somewhere floating up as we look at this in the first quadrant. Okay, so I'm going to make this triangle. And what I'm going to do then is draw the height like we did with the law of sines. Actually, I don't want to call that height. Let me change that in a minute. But like the law of sines, we want the height to be included. And the reason I'm not calling it H is because I want to talk about how I got there. To get to point C is a random point x, y out in the coordinate plane. And to get there, here I want a distance of x, and here I want a distance of y. Now as I label my triangle, Across from angle A is side A. So this length over here is side A. Across from angle B is side B. And this whole distance here is side C. So can I label a point? Well, I know this is 0, 0. If this whole length is C, then this is the point C0. All right, I have everything labeled, and so we want to do two things. The first thing we want to do is find x. Well, in order to find x, I'm going to relate it with angle A, okay, and I'm going to do everything in here with angle A. How do I use angle A to help me find x? Well, I have this right triangle. X is the adjacent side, and B is the hypotenuse, so I'm going to use cosine. I'm going to say the cosine of angle A is x over side B, and like we did before, let's rewrite it for x, is B times the cosine of angle A. I'm going to do the same thing. I'm going to find y for the second thing. And if I look at still angle A, I know that the sine of angle A is y over B. So I can say that y is B times the sine of A. Okay, so third thing we're going to do, because I now related to angle A, I'm going to go to side A. So I'm going to find side A. Okay, and in order to do that, I'm going to use Pythagorean theorem. And let me change colors a second so I can show you what I'm working on. I'm going to use Pythagorean theorem to find this triangle because that gives me the length of side A. So I know this length is y, I know this length is A, and this length right here is the whole value of C minus the x. Okay, so here I go. I'm going to go Pythagorean theorem a second. A squared is the same thing as C minus x squared plus y squared. Okay, let me FOIL this out. If I FOIL this out, I get c squared minus 2xc plus x squared plus y squared. And now I'm going to go back to my drawing a second. Because this x squared plus y squared, if I look at my drawing, that's this other triangle. So if I look at this x squared plus this y squared, I get b squared. So I'm going to rewrite this again. C squared minus 2, and I'm going to replace the x with what I found before, b times the cosine of A times, I don't want to forget that c, plus b squared. Now I'm going to rewrite this a second. A squared, and I'm going to put it in the order you're used to seeing. B squared plus c squared minus 2bc times the cosine of A. And this is one version of the law of cosines. Now we know that there are 3 versions, and you could rearrange how the triangle looks, but that's one version. The other one, we're actually going to put on the back. So I'll wait on this. Okay, and so this is how the law of cosines came about, but this is one way. There are multiple ways, but this is, in my opinion, one of the easier ways. Okay, so let's try using the law of cosines a second. I give you an angle A that's 29 degrees. Okay, so let's do this is 29 degrees, which is A. Side B has to be smaller than side C, so C has to be the bigger angle of 12, and B then has to be 9. So this one's A. Okay, and you're labeling your triangle based on what you know. Okay, I'm going to start by finding side A because I know angle A. So I'm going to say in order to find side A, we know that A squared, according to what we had before, is b squared plus c squared minus 2 times b times c times the cosine of my angle 29. Now, this is all numbers, so just stick that right in your calculator. You end up getting that a squared is 36.08. So to find side A, you square root. We don't want plus and minus because you can't have a negative side length of a triangle. So you end up getting 6.01 for side A. Now, does this make sense? Well, as I look at this, I can see already that A is the smallest side. Therefore, A probably is going to be the smallest angle. Now, I forgot to put my geometric condition, but let me look at this again. Side with an inclusive angle, then another side. So side, angle, side. And finding a side length with law of cosines is really easy. It's finding the angle that's the hardest. So I'm going to find one angle, and then we're going to use the idea that a triangle adds up to 180 to find the other one. So I'm going to start with angle B. Okay, in order to find angle B, here we go. I set it equal to B squared. So 9 squared equals, and I use my two other sides, 6.01 squared plus 12 squared minus 2 times 6.01 times 12 times the cosine of B. Now here's what I'm going to do. I'm going to add these two together first. 9 squared is 81, and if I add 6.01 squared plus 12 squared, I get 180.1201 minus, now I'm going to multiply these three together to get 144.21 cosine of B. The biggest mistake that people make is they then subtract these two numbers, and you can't. The 144 is tied with the cosine. So we got to get rid of the 180.1201 on both sides. You get negative 99.1201 equals negative 144.21 cosine of B. We divide by negative 144.21. I know this is getting a little small, but you end up getting that the cosine of B is 0.6873. And like we did in the law of cosines, to find the angle, we inverse cosine. So we inverse cosine 0.6873, and you get about 46.58 degrees. You know what? Let me make sure you can actually read that. 46.58 degrees. Okay, so how do you find angle C? Well, angle C is 180 minus 29 minus 46.58, and you end up getting that angle C is 104.42 degrees. Okay, and so law of cosines ends up taking a lot longer than law of sines, but we are going to try and show you why the law of cosines is so nice. Okay, and so that's one example. If you flip to the back, let's do another one. And we're going to start first with what the law of cosines is. We did the first one. A squared equals B squared plus C squared minus 2BC times the cosine of A. And the biggest thing that you keep in mind is if it's side A equals, then cosine of A has to be in the equation. The other one you have is B squared equals A squared plus C squared minus 2AC times the cosine of B, because again it said equal to B squared. Last one, C squared equals A squared plus B squared minus 2AB times the cosine of C. Okay, and the way we say it is the square of one side equals the sum of the squares of the other two sides minus 2 times the product of the two sides times the cosine of the included angle. And it's kind of a mouthful, but again, we want you to understand where things are coming from. And so our next example kind of ties into actually what we did in our proof of how to get the law of cosines. What happens with the law of cosines if C is 90 degrees? Well, since they're giving you angle C, let's set it equal to C squared. A squared plus b squared minus 2ab times the cosine of 90. Well, let's talk about it. The cosine of 90, if we go back to our unit circle, is just 0. And because this is 0, this whole piece will cancel out. So what are you left with? You are left with Pythagorean theorem. And so what's great about the law of cosines is it's just a modification of Pythagorean theorem, and it accounts for the fact that the angle then isn't 90, so it accounts for how do I deal with it if it's not 90. Okay? We're going to give you a word example, a story problem, and then I'm going to show you the other area formula, and then we'll be done. I'm going to move this up a little bit. Okay, Ann Arbor is 42 miles due west of Detroit. Okay, so Ann Arbor is due west of Detroit. Let's draw this. If here's Detroit, due west means you head west. Heading west, you get to Ann Arbor. And I'm going to shorthand this a second. It is 42 miles due west of Detroit. Flint is exactly 54 miles from Ann Arbor. And I'm going to put it here. 54 miles from Ann Arbor. I'm just going to call this F for Flint. And 70 miles from Detroit. What exact direction should the plane head from Detroit to Flint? And so what angle, what exact direction, they mean what angle from Detroit to Flint. So they're actually asking what is this Detroit angle? I'm going to call it X. You can kind of call it whatever you want, but because we're dealing with Detroit's angle, we are going to use 54 miles to set it equal to. So 54 squared equals 70 squared plus 42 squared minus 2 times 70 times 42 times the cosine of x. And we're trying to find out what exact direction means what angle should you be heading from Detroit to Flint. All right, let's see. These are big numbers. So 54 squared is 2,916. When you do 70 squared plus 42 squared, you get 6,664. When you do 2 times 70 times 42, you get 5,880 times the cosine of x. Now again, don't forget, you cannot subtract 6,664 from minus 5,880 because the x is tied with that. So we're going to subtract 6,664 first. You end up getting negative 3,748 equals negative 5,880 cosine of x. We divide by negative 5,880 on both sides. You get that the cosine of x then is 0.6374. So to find the angle, we inverse cosine, and you get about 50.40 degrees. If you want to just say 50.4, that's fine too. But that's the idea, is you're going to probably need your picture in order to be able to figure out which side relates to which angle. Okay, so there's our story problem. Last idea is the other area formula, and you'll notice in that last example, we gave you all three sides. And so when you're doing the area of a triangle, given all three sides, we call this, sorry about that, we call this Heron's area formula. And that's probably what you recognize this from Algebra 2. But you end up getting the square root of s times s minus a times s minus b times s minus c, when s is 1/2 times the sum of all three sides for a triangle ABC with sides A, B, and C. okay? So we give you three sides. Basically, you're going to use Heron's area formula when you're given three sides of the triangle. Okay, so before you do that, though, you have to know S. So I'm going to start with S. S is 1/2 times the sum of all three sides. You end up getting that S then is 16. So in order to find the area, you do the square root of 16, and then you do 16 minus the first side, 16 minus the second side, and then 16 minus the third side. And I tend to simplify this before I put it in my calculator. So you have 16 times 8 times 6 times 2, which is the square root of 1536. So my area is approximately 39.19 meters, because meters is our unit, meters squared. I don't need to go that far. There we go. Now, we're going to give you extra credit if you can draw this triangle and find the area of it, not using Aaron's formula. So you could use the basic area of a triangle from geometry. You could use the area formula we used yesterday, where you take 1/2 times the product of the two sides times the sine of the included angle. You can use any method you want to find that area, but that needs to be done on a separate sheet of paper, and that is due quiz day. Okay, and that will go towards the first quiz. I will add that to your first quiz. Okay, that's the end of section 6.2, law of cosines. Tonight's homework is a worksheet, so please make sure that you're using law of cosines for as much of it as you can. I know there's one question where you can use the law of sines to start, but for the most part you have to use the law of cosines.